Hi guys, if you have been into AI engineering and agentic development, I'm pretty sure you have suddenly started seeing a lot of videos which are talking about loops. Suddenly everybody is saying that you should use loops as a part of agentic development. And then there are other set of people who are saying that loops are dead, don't use it. But as they say, the devil lies in the details. So I just wanted to spend some time in trying to declutter this particular topic, basically trying to explain what is a loop, of how it works, are there any different types of loops, what are the pros and cons, and should you use them, or in which case you should use them, and in which case you should not use them. So let's quickly get into it. Folks, co-tutor here, and my name is Anil Deshpande. Here is a trivial job, which is renaming a variable. Nothing about this needs to repeat. And so far, it has not cost us anything or nothing significant. However, let's assume that we now start to use the loops. We run it once, even a single pass through a model costs some tokens. Let's assume that it's around 5,000 tokens here. But we looped the same trivial task 3 times. The bill climbs to 15,000 tokens for the work that never needed a second pass. One pass would have done it in 5,000 tokens. Looping it made the same job 3 times more expensive for the same exact result. So a loop we did not need cost us 3 times more for nothing. But to judge that fairly, we have to be precise about the thing itself, that is looping. Before we fill it in, here is the shape. A loop is just 4 steps arranged in a cycle. That is all it is. The 4 steps are basically we observe what happened, then we decide what to do based on the observation, and then act on it using some tool calls. And then we get the final result, but we have to evaluate the result. And the last arrow, that is from evaluation to observation, loops us right back into the start of the loop. That repeat is what makes it a loop. One trip around the cycle is one iteration, and it keeps going around and round. The counter climbing with every lap until something tells us to stop. If you try to understand it with a realistic example, here is what it could actually look like. You run the test, read the failures, edit the code, and then once again rerun. The loop is still turning, and each step depends on the result we cannot see until we run it. And it keeps turning until the test pass green. That is the stop condition. So a loop should have a stop condition, otherwise it's like getting into a infinite loop, and that's not a good idea. And it is the only thing that ends the loop. And that is why loops have suddenly taken over. The loop reaches a result a single call can't guarantee. That is the power used in the right problem. So the loop that you have seen here is not the only shape of loop that you will encounter. The shapes can change depending upon the behavior that you want to capture. There are basically 4 types of loops or shapes which you will actually run into. For now, these are what the 4 loops look like: react, plan and execute, reflection, and reflexion. React is nothing but reason plus act. It's the default agent loop. You might have seen it when you see a agent working. It says that it is thinking about a particular chain of thought, and then it finds out it needs to act on based on what it thought about, and then it acts and then observes the output. And this is the loop that most of your codecs, cloud code, any of the agents will be going through when you are doing the agentic programming. And this is a repetition loop. Then you have a plan and execute that basically makes the whole plan upfront all at once and then runs straight through them. You might have also seen this, wherein most of these coding agents have something called as planning mode. So you plan what you want to implement, and then once you make sure that the plan is watertight, you ask the agent to execute it. And this is a repetition loop. You plan, you execute, then you create a next plan, and then you execute that particular plan. Then the third one, which is reflection, which is critiquing itself. It basically generates a draft, it critiques its own work, and then reproduces refactored or refined draft. This loop is mainly used when you want to ideate on, say, for example, an architecture, or when you want to critically review architecture documentation, ADRs. That is where this kind of loop comes into help. And then the fourth one, which is reflexion, which is nothing but a react, that is the first loop with a memory. It first does the react loop, that is reason and act and observation, and then based on failures that it encountered and it fixed, it writes those failures into a memory so that it becomes a memory augmented react loop. This is also something you will see developers doing. They execute, and then at the end of it they will say that harvest the knowledge, which basically goes through the whole conversation and then identifies how the whole thing went about, understand where things failed and how they fixed it, and then they write it down into a memory file. So going forward, that itself acts like a feedback loop for the agent to not to repeat those mistakes. So that is how you improve the performance of your agentic development workflow. Other than these four loops, you might come across many other loops. Some say that there are 7 loops, 8 loops, 12 loops, but broadly speaking, these are the major 4 loops, and then there will be a few minor changes here and there, minor nuances. But here is what they all share. Every one of them is a full model call, every single iteration. More loops mean more calls, and more calls mean more cost. Every flavor builds the same way. So let us follow the money and see what looping actually costs us. Let us start with a baseline. One pass through a model costs, say, around 5,000 tokens. Loop that same work 3 times and you will end up paying 3 times, that is 15,000 tokens. But there is a cost you don't see, the iteration that failed or got thrown away, because every time the model might not give you or may not give you the expected result that you were looking for. So in that case, you basically throw away or undo the work that the model did. However, they still get billed. So the real total is already higher than what it actually looks. Now add a verifier, a second model that checks the work. It runs to roughly doubling the whole stack again. So looping costs more than what it appears initially. And here is the twist. Adding more steps does not even make it more reliable. Let us see why. Say each step is 95% reliable. On its own, that looks great. One step, 95% accuracy, feels great. Add second step. Now both have to succeed. 95% of 95% is 90%. A third step, and we multiply again, about 86%. Every step we add is another chance to fail. Keep going to 20 steps and it collapses. 95 multiplied 20 times is only about 36% reliability. Make every step better, 99% each, and it climbs back to 82%. So better steps shift the curve, not the number of steps. So we have counted the cost and watched the cracks. But here is a quieter problem. If you do loop, here is the hard part. Not running it, but trusting what it did. Start with the maker, the model that produces the work. The trouble is the maker is too generous, grading its own homework. Left alone, it will tell you that it's done when it actually isn't. And we have actually seen it. Some of the earlier Cloud 4.6 models used to suddenly declare that we have implemented, but when in actuality it did not. That is where these some of the Ralph Vaughan loops came into picture. So split the maker from the checker. A separate model, sometimes a stronger one, takes over the done gate and checks the work against the reality. It runs the tests, compare the specs. Not done, it goes back to the maker. That is the verification loop. Done, ship it, but done is a claim, not a proof. The checking, the judgment, that stays with you. That verification loop is the one nobody argues against. But it leans on a word we have never actually pinned down. And getting that word wrong is exactly what makes people overbid. Let's try to fix that. We keep calling every loop an agent. The word gets used like they are the same, but they are not. And the difference changes what you build. Here is our loop again. Is it an agent? After every pass, it reaches one decision: go around again or stop. Who makes that call is the whole question. If the code you wrote makes that call, if the tests are not passing loop again, then your code owns the control flow. That is a workflow. Now flip it. If the model itself decides whether to go again or stop, the model owns the control flow. That and that only makes an agent. Notice the loop did not change. And here is the catch you might be feeling. You might have written prompts, skills, and even the agent itself. But at the runtime, the model still makes the call. Authoring prompts, skills, and sub-agents is not same as owning the control flow. So the loop was never the deciding factor. The same loop is a workflow when your code drives it and an agent when the model drives it. A loop is not an agent. Same loop, different owner. This leaves the only question that matters in practice. Should you reach for the loop at all? Loop is not a silver bullet. Most tasks, rename variable, format some JSON, answer a question, just need one good call. Looping them only costs more. A loop is earned only when the work actually needs it, when it interacts with an external environment, when it has to verify its own output, or is iterative discovery where next step depends on the last. Then earn it responsibly. Number of iterations will have to be capped. The stop conditions will have to be clearly well defined, and you have to keep a very good tab on the budget. Otherwise, don't reach for the loop by default. One good call or a plain workflow will do or should do. The cheapest loop is the one you correctly decided not to run. And when you do loop, ensure that you stay the engineer. It runs while you are not watching, so you verify what it shipped, you read what it changed, and you keep your own judgment. So I hope this brings in the clarity of what loops are and should you use them or should you not use them. There are two camps. Some are saying you should use them and other one which says you should not use them, but the reality is somewhere in between. And do comment down in the comment section which loops you are using and which are giving you the most results, and in which cases you actually don't use loops. Thanks for your time. That brings us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.